Good morning, everyone. Today we are going to look at energy and power in electrical circuits. Now, energy is not something new. We've used a lot of energy, and as with other energies, energy is just measured in joule, and here we're going to use a W for the electrical energy. Now, you've already seen that when we defined potential difference, we talked about energy per unit charge. Now, just rewriting that to get the W in front, we'll do W equals VQ, or you could have replaced the Q with I times delta T, and all the other equations that you can substitute in give you a number of different options. And now all these are on the information sheet. So you can use any one. It's just a question of seeing which variables do I have and what am I looking for. Now let's look at the first example there. Calculate the amount of energy. So I'm looking for the W that is needed to send a current of 2 amps. Okay, 2 ampere, that will be the current, that is I. For 10 minutes, that's delta T. And important, we don't want that in minutes. Time must be in seconds. So I'm going to multiply by 60, and then I end up with 600 seconds. And then we are told through a 2 ohm resistor, so I've got R as well. So now I just need to find the equation over there on my information sheet. And remember, with the CAPS grade 11 and grade 12, they're going to supply you with those, and you just choose the one that's most helpful for you. So that will be W equals I squared R delta T, I then being 2 ampere, or 2 ohm, and time just need to be in seconds. And when you do that, you end up with 4,800. And now, since we're working with energy, that's just going to be joule. So that was very easy, and that was close to what we've done already. Now we're looking at power, and power is very important, because you buy implements by looking at their power. You want to buy a microwave oven, you've got an 800 watt and a 1200 watt to give you an idea of how much energy this appliance is going to give you per second, because power is all about the rate at which energy is converted or used. Now, if you have a light bulb, that is converting electrical energy to light energy. If you have a heater, then that will be converting electrical energy to heat. So it's only converting. Remember, energy is not destroyed. It can only be converted to another form. Now, if we look at that one, then that first equation is the one that is going to give you that definition, right? Is the rate. Now, whenever you divide by time, that is rate. So it's the rate at which electricity or electrical energy is converted to others. So if you had an old-fashioned 100-watt bulb, that meant 100 watt, or you also got that in 60 watt. 60 watt would have meant 60 joules in every second, right? 60 watts, 60 joules in every second. So a 60 watt lamp would provide less light energy than a 100 watt bulb. But we are not using the old-fashioned bulbs anymore, because what they did is they actually converted electrical energy to a lot of heat energy as well that we don't want and we don't need. Remember, if they tell you 60 watt is equal to 60 joule delivered in 1 second. That also tells you if you buy a hairdryer or a microwave oven or whatever, the bigger the power, the bigger the energy delivered per second. But remember, that will cost more. When you look at the brightness of a bulb, that is determined by the power. More power means more light energy per second. When you were in grade 10, your teacher also asked you which bulb is brighter, but then you haven't done power yet. And then if she gave you a question like this, and she asked you which bulb is brighter, she said something else. She told you that the bulbs are identical. Now in grade 11, we know we're not supposed to look at current. They only told you look for the biggest current, and A has got the biggest current, and therefore it will be brightest. But that's only true if you have identical bulbs. Remember, if they are identical, it means R is a constant. And we now have an equation that says P equals I squared R. So if R is a constant, then yes, I can look at the current, because the bigger current will be the one with the bigger power, and that will be emitting more light energy per second. So in grade 10, they restricted that to the same resistance, and then you can look only at I to determine P. But when we get to grade 11, we now are going to give you things with different resistance, and then going to ask you which one is brighter. So let's just do the first one there, 8.2. 20,000 coulombs of charge, right? So they give you a Q, moves in 2 minutes. I will make that delta T and not minutes, 120 seconds. Through a resistor with the potential difference, and there they give you a V, and they ask you to calculate P. Now, none of the equations over there has got a Q in there. So let's just get rid of Q first. Q, I have an equation that tells you I delta T. So for this one, they give me Q, that is 20,000, and they give me delta T, 120. So that tells me the current over there will be 166.67 ampere. Right, and then I can go to P, because now I've got I and V, and that's one of my equations. P equals I times V. Right, so it's 166.67 times the 12, and then you end up with 2,000, and that is watt. 2,000 watt. Now we've talked about that question where in grade 10 they gave you identical bulbs, and I was a good indication of P. Now I give you a question where you've got two bulbs with different resistance, and the moment they ask you which one is glowing brighter, you have to know I have to look at P. I cannot look at I, because now we've got a different R. First off, they're asking me about things that are in series. Now when they're in series, let's just think about this question. They are asking about P, right? So P is my dependent variable. It's the one that depends on what I'm going to do, right? I want to know what's P. That's my dependent variable. What are they changing? They're changing R. So R is my independent variable. That's the one they're changing. That's the one I want to know, want to measure. And now, when you look at 2, remember all the other variables must be kept constant. Otherwise, they will influence the power. So if you are in series, what is constant? What is the same for things that are in series? In series, the current is the same for both of them. So the current is my constant variable. And that means I'm going to look for an equation that's got R and P and I. So if we look at the equations, you had P equals I squared R that I can use there. So P equals I squared R, and now I is a constant. And if that one is constant, it means P is directly proportional to R. This one is constant, so if this one doubles, then the whole right-hand side double, and then the left-hand side will double as well. They will increase or decrease with the same factor, so they're directly proportional, which tell me the one with the bigger resistance will be the one with the bigger power, and that means will be emitting more light energy per second, right? It will be brighter. So who's got the bigger resistor? 2R is got the bigger resistor, so 2R will now be brighter. Right, but then we also have to do the same thing when they are connected in parallel. Now in parallel, what will be the constant? Now if they're in parallel, remember the potential difference over the top and the bottom is the same. So for them, V is my constant. So now I need an equation with my dependent and independent and V, because I know V is a constant. So if I look at all the available equations, I'm going to use P equals V squared over R. And the reason why I use this one is because I know that one is a constant, and then P will be inversely proportional to R, which means the bigger the R, the smaller the P. So who's got the smallest resistance? From those two, that will be R. So R will be brighter, right? It's got a smaller resistance, but resistance is inversely proportional to power, so it will have the bigger power, right? And if it's got a bigger power, it means more light energy per second. So guys, when you have things like this, look for the dependent and the independent, right? Dependent, the one they're changing, the independent, the one you are looking for, right? And all the other variables in your equation must be kept constant. So you need to choose your equation according to dependent, independent, and knowing what is constant. Right, in the next video, we'll look at the cost of electricity.